Good day everyone, welcome back to my channel. Today I'm just going to share with you my experience on PC building and the airflow of a case. Now this is going to be very lengthy and there will be some history about myself, so if you guys find that it's not relevant on my history, you can actually skip to a further timing where I'll talk about the current sharing that I have for you. And of course, I am not a professional PC builder. This is just a hobby, and I'm far off from those who actually does custom water cooling. Right in front of you, in fact, is my configuration on my processor using the motherboard, the Turbo Boost. I'm actually using an Intel Core i5 9600K processor that runs at 3.7 gigahertz, and selecting it to turbo boost at 4.8 gigahertz. But so far I've actually not maintained to this speed due to the fact that I am actually using the XMP profile on my RAMs, which enables me to run at the memory speed of 3200 megahertz. And most of the time, right, when this runs, right, my processor will only hit up to 4500 megahertz. Now I've actually bring up all this and I got to say this, that I'm not a professional overclocker. I'm just showing you that what is actually going on. Having with all the configurations set up, right, this is actually my idle time. I'm not too sure if you can see it. So it hovers between 34 to 36 degrees Celsius. Let me just bring this up, probably it will be better. So these are actually all my core that is running currently, and due to the fact that the weather is hot in Singapore right now, my case is not open, it's actually closed, and the temperature ranging in the room itself, right, it's about, I should say, about 29 to 31 or 32. Then I have no aircon on, so I'll just run the ceiling bench. But before I do so, right, do take note that I will be running off, I will be running the GPU overclocking too. So I've actually set my GPU to core clock speed to plus 190, which will hit, instead of the default 1600, right, it will go all the way to 2100. Then for my bus speed itself, right, I mean the memory speed itself, right, I've actually plus 70. I've not increased at any voltages because I don't want to warp my GPU. Now this is just a run. Take note on the temperature itself, which I'm going to show you here on the actual statistics. I'm going to run 3 rounds so you can actually see how much temperature that it goes. So this is actually the first run. Okay, while it's actually increasing in temperature itself, right, my fans start to kick in, and it will ramp up to probably, I will say, for the front fan, right, it will be like 100 and it's about 1600. Then my top fan will be like 1300. To illustrate all this, right, the CPU fan, in fact, is CPU 1 fan, in fact, is my pump for the processor itself. My CPU 2, in fact, is the top airflow fan that is actually taking intake. Then case 1, right, this is actually, chassis 1 is in fact my rear fan, which is actually a gentle typhoon. It's running on full RPM. Supposedly it should be rated at 1800 RPM, but it's running max at 1700 plus RPM. My chassis 5, right, in fact, is my front intake fans. They are the Arctic pressure fans. By right, it should be running at 1800, but somehow maximum it can go is about 1700 or 1600. Then my chassis 6, right, in fact, is my GPU AIO, the pump itself. I'm running on full speed. 4 and 2, there isn't any. Sometimes it just give random figures, I wouldn't know why. But so far, these are all the fan RPMs that's wrapping up. Now, as I talk to you, right, look at the temperature itself. I'm still running on ceiling bench itself. So I should say that I will not hit 74 degrees Celsius. Probably, I guess, the calculation on the airflow that I did correctly. So I just let it run. Okay, this is actually the first test. Now to run the second test. So to be a fair judgment on how I actually calculate the airflow within the case itself. Now a lot will actually ask me, do I actually do fixed overclocking on my processor and on my RAMs? Answer is no. Reason being, right, later on I will explain during the full introduction or in-depth details of what I do with this case or some sharings. But just as a tip, having a fixed overclock voltage and bus speed, it can actually harm your motherboard and your processor, so it's a no-go for me. And also it might warp the motherboard itself. Same goes to the GPU. I will not stay at fixed. Most of the time, right, if I do not need the speed, right, I will not clock my GPU. I'll just let it run by itself. So as you can see that my CPU is actually on 100 load, and the temperature, it hovers between this degree. It's actually between from 68 to either 72. Max it goes, right, it's about 74. So this is actually the second run. Now as I mentioned to you, my core speed on the processor itself, right, it will never hit more than 4500 megahertz. It's always around this megahertz. I'm actually fine with this. Now coming to the end of the second run, I am doing the third run right now. As you can see, it decreases because my Cinebench have stopped. So I'm just going to run the third run. So here we go again. It's going to ramp up again. As you can see, earlier on it toggles 74, but it doesn't stay on 74. It will just stay at 70, 71, 72, and that's it. And another question is that you might ask, why didn't I actually overclock it further? I don't feel there is a necessary to do so because I don't play games. I want stability from the machine itself, or should I say the PC itself, to actually do my editing work, to do my 3D rendering, and etc. I mainly make use of the PC for Camtasia Studio, Adobe Premiere, and of course some 3D AutoCAD stuff that I do for work. So basically on my PC itself, right, I'm just doing video editing, some graphical kind of stuff like Photoshop, Illustrator and such. Now this is actually out of the norm itself. There are people asking, should you be running the M.2 SATA just at the default degree at 50 degrees Celsius and so? I would emphasize on this. SSD, M.2 SSD itself, right, will not just die like that. In fact, they are happy to actually have the heat on them. And surprisingly, right, with heat, right, they perform faster as compared to having a cold, I should say a cold surface. But of course not over-throttling. If you were to do the over-throttling itself, right, it will slow down the read-write speed. So most of my time, right, my M.2 SDs, right, they are actually hovering, as you can see over here. It's about 40 to 50 degrees. So I don't really put heatsink or to cool them down. There is no necessity for it to actually cool down. Okay, I've actually done my third run. So looking at the core itself, right, as you can see, it stays within the 71 to 74 degrees Celsius at 100 load. Now I'm just going to switch over. Okay, leaving this on. I'm just going to switch over to Valley itself. So take note on the core speed and the temperature of my GPU itself. Now I'm not going to run a full screen, just to run at running at 1080p. So when I do the benchmark itself, right, take a look at this, and probably you can actually see this, the FPS. I'm not too sure if you can see it. Okay, I do not really know how to actually set the floating point. Okay, as I mentioned, I'm not actually a professional overclocker, but sitting over here, right, It's actually running on my graphic card is actually 2100 megahertz, and the memory itself, right, is running at 4074, which I've actually done the clock. And as you can see, right, with the case closed, I'm still running on this. The temperature is amazing. It's like I never hit beyond 65 or 70. Be whether I actually run full screen or not, it does not go beyond there. See, as you can see the temperature curve here, if I detach it. Yep, temperature. Then the GPU usage, it is consistent. And looking at the hardware info itself, right? Okay, let me just switch off the sound if I could. No, I can't. Okay, probably I'll do this now. Looking at the stand that my GPU itself, right? If you to see, right, it's actually running on 100 load. Then the temperature of the card itself, okay, it will never hit more than 60. It will just keep going. The max so far I've actually reached, right, is actually 60, which I've done extensive overclock on Afterburner itself, but I don't realize what's the difference on it when I play back videos. And maybe if you play games, right, you'll feel the difference, but I don't feel the difference, so I don't feel there is a need to actually do the extreme to overclock it. Okay, I will do another run for this value itself. Okay, I think it's about to end. Yep. Okay, so here you go. So I'm hitting about the FPS itself, right? It's about 205 and the minimum is 34. I know it's nothing great, but so far I'm actually enjoying the stability of this GTX 1070 Ti Mini, which I've actually done my mode itself, which worked. And originally, right, my card in fact is not working because the person who actually sold me this card, right, he did not maintain the card well, and there is thermal throttling due to the fact that one of the fan is actually failing. So I've actually dismantled the whole heatsink and the cover of it, and I've actually done my own mode. So if you're interested, right, you can actually see the other video how I actually go by doing the mode on the graphic card itself. Okay, I'm just going to run another time. I do apologize that you guys have to actually see this whole process itself. I just want to show you the end result, then to explain to you how I go by setting up my stuff on the casing airflow and the GPU itself. Okay, it's still running on the background. Okay, still hovering at the degrees of 56, I should say around 55, 56. It doesn't go beyond that. And do take note that in my case is fully closed, not open. I didn't open up all the panels, I didn't open up the front mesh or to take out the fan filters from the top, which is drawing air into the PC itself. And later, at the end of the video, right, there will be another reading too, so it will show you that I seriously have not done any tampering while I'm actually doing the testing to show you the results here. The GPU itself, see, it does go max, I should say 57, and it's right now on the second run hovering at 56. Earlier one was around 55. Then the load, it's like 90%. Oh, and I did attach my own fan, I should say additional fan, which is actually a 60mm fan onto my graphic cards when I do the mode, and this fan is connected directly to the GPU itself. So I just let the GPU detect and to run the RPM on the fans itself. When it's at full, right, the fan on my graphic card in fact will hit about 2400, but before doing the overclock and running at full load, right, most of the time it's actually running about 15%, so I should say it's about 1100 RPM or so. So it never go beyond crazy stats, or should I say hearing the whine noises. Now I've actually deliberately cut the video itself because I wouldn't want you guys to actually wait that long. So this is actually the end results that I got after 2 runs. Not gonna do the 3rd run, but looking at the stats on hardware monitor itself, right, as you can see that this tells everything. My max it will go on my GPU itself, right. Okay, let me just pull down. Yep, it will be around 58 to 60. In fact, some of the time it does hit 61, but majority of the time, right, it's actually below 60, and I normally let it hover around 55 to 56. And my card itself, as mentioned, right, the GTX 1070 Ti is overclocked and it's running on 2100 megahertz and with the memory speed of 4074 megahertz. So yeah, now if you guys are interested to know how I actually achieve this so-called average or moderate clocking, right, on both the processor and the GPU itself, right, I'll explain more how I did on the case airflow itself at the following part. Now do note that this is going to be very lengthy, so if you do not have the time, right, I would suggest you that probably you can actually just try and error by yourself, figuring how to actually do the airflow on the case itself. So I'm not going to waste too much of the time, so let's proceed. I know this case here is pretty ugly. In fact, this is actually the very first case that I actually started with PC building. That was year 2000. Just something about myself. My name is Cleo and I'm from Singapore. Back then, right, case molding, or should I say PC building, right, it's actually a very in thing as compared to right now. It's not as challenging as in the past because most of your modes, right, like RGBs, ARGBs, and those so-called LED strips and such, and those fan holes and ventilation vents, etc., you don't have to actually cut them. All you need to do, right, is just to get it off from the bookshelf or maybe ordered online. For those of you who actually want to know more on my history itself, right, on how I started off PC building. Now, if you were to actually go to my main YouTube channel itself, right, this is actually the main channel where it highlights all the videos and playlists and etc. Now, on the right hand corner, it says Godzilla the Making. When you click on this, right, it will take you to this page, and this is actually currently it's actually dead. Okay, I've actually not done any updates, so this is whereby you can actually see that what I've actually done and how I came about with the name Godzilla and such, and all these are actually my experience. Now, from a very simple case itself, right, back then, case molding, like cutting holes of the side panels, the top, the back, the front, etc., it's very challenging because you have to actually do it yourself. Now, earlier on, I've actually shown you the case. This is actually a Lenly PC12, and from this, right, I have actually done the transformation. Let me just take you to the final page. This is how it become. From that down looking cases whereby I did the cutting on the top for ventilation, the side panel, the window panel, and of course the side I should say fan holes, and not forgetting the back. I actually have to punch out another hole just to draw hot air out. Besides this, right, this page itself, right, does highlight things like the past mode that I've actually done. It's just for knowledge base itself. So these are actually all the modes that I've actually done, and some ideas on how to actually do the cleanup, and of course the tools that I've actually used. I've actually highlight them out. So if you are interested, you can actually just drop by to this website. Now let me just go back to the page. Back to the current situation whereby how I determine a PC build, or should I say begin a PC build and to calculate the airflow itself. I have three main categories. First is the usage of the PC. Second, the case factor. Third, the fan factor. Now, starting off with the usage itself, it depends greatly on the user what they want to do with the PC. The first type of user will be for leisure and light work, mainly used for surfing internet, watching movies, using office applications like Office 365, Word, Excel, PowerPoint, and etc., and to do light gamings. This PC do not really generate too much heat. Next will be for professional work. Besides using the PC for leisure and light work, they mainly use this PC to do graphical applications, video editing and 3D rendering. Applications like Adobe Illustrator, Photoshop, Premiere, Camtasia, AutoCAD, 3D architecture work. Now, these PC generate moderate heat, as they do make use of things like 3D rendering, video compilation. Last will be for gaming. Besides the above usage, user mainly use the PC to game, and this PC generate the most heat. Reason being, right, majority of the gamers, right, they will actually like to optimize the performance of their processor and the graphic card itself. And having to say so, right, some might do extreme overclocking. The next factor will be case factor. Is the case heavy? Well, to me, right, as I build PC, right, be it for myself or for my friends or for my relative, I would judge on how heavy the case is, because some elderly, right, might not be able to actually carry the case. So that's one of my main concern. Next will be the features of the case. Is the case structure sturdy? What type of material is made of? Either aluminum or steel. Inclusive of the fan filters, nicely built, or is it just a cheap kind of fan filters? And also accessibility, whereby are there room for me to actually route the cables on the routing holes and things like that. And of course, the main thing will be airflow. Is it spacious, and where the fan mountings are, whether from the top, from the front, from the back, and from the bottom. And is there a fan mesh at the front bezel, which is actually quite important too. And last but not least will be the price versus value, because some case might be very premium. You paid a price for it, it looks good, but some of the features that I wanted, right, might not be there, so might not be value. So these are some of the factors that I will consider. Now take a look at the right hand corner, whereby I actually draft out something which I always use, thumb of rule. On the case itself, right, I've actually split into 3 zones. The most top zone, which is actually zone 1, the CPU area, this is where it generates heat on the processor itself. Next will be zone 2, the GPU area or the graphic card area, whereby the graphic card itself, right, will generate heat. And last but not least, which is actually zone 3, the PSU area, where your power supply, right, when it runs hot, it will generate off heat. Now you might ask, why do I actually split this 3 zone itself? Well, that is actually for my calculation. Later I'll be showing to you basically how I actually counter attack on the hot air itself, and where the cool air comes into the case itself. The last factor that I will consider is actually the fan factors. Whether do you want an RGB or non-RGB? Personally, I will take non-RGB fans. I would prefer to get performance fans, and if I want RGB, right, I can actually make use of the Fantex Halo. Next will be the dimension of the fans. Dimension is also another factor, whereby come in sizes like 120mm, 140mm, 240 or maybe 280. The larger it goes, right, you'll be more quiet. Reason being, right, the larger fan, when you even pump at low RPM speed, they still draw much more air compared to 120mm running at full speed. Next will be the performance of the fan in terms of amperage usage. or should I say current drawn from the motherboard fan headers to your fan. And of course the CFM, which is the strength of the wind from blowing through the fan or to actually pull from the fan, known as the cubic feet per minute. I will talk about the amperage itself, why I'm so particular about this. Now, in each motherboard itself, right, there is an indication on how much amperage a fan header is. For example, for non-premium boards, right, normally you come with a 1.0 ampere limit. So imagine that you have 5 fans that is actually rated 0.25. So if you do times 5, right, it's above 1.0 ampere. So if you do daisy chain these fans together and plug it to one header, your motherboard will be overloaded, and in no time, right, you will just blow off the fan headers. So do take note on that. And for CFM itself, a lot of professional, or should I say reviewers in YouTube, they make use of an equipment to measure the strength, or should I say the wind current, on how much this fan can blow and to draw. So for me, right, I will depend much on feeling. When I test the fan itself, right, I will just gauge based on the strength of the fan through my hands and through some paper illustration. Probably I'll do up another video regarding about how I actually judge fans based on CFM itself. Next will be 2 sections whereby whether the fan itself is actually static pressure that is meant for radiators, or airflow, which is actually meant for the case airflow. There are some static pressure fans not only meant for radiators, but you can actually use it for airflow. So far I can only think of one, but it will still be advisable to actually make use of static pressure fans on radiators only, and to make use of proper airflow fans for case airflow. Next will be price versus value and performance. This question, right, have prompted to me whereby there are people who actually ask me, hey Kyo, why don't you make use of Noctua, the AF12 or the AF14? Yes, no doubt, those are very good built fans. They are quiet, but taking the price itself, right, I would have actually purchased 2 fans instead of 1. Okay, I'm not a fanboy at Arctic, but most of their fans, right, they are well built and they are cheap and they does the job. If the fans were to fail, right, I can just replace another similar fan. And one good thing about Arctic fans, right, you can actually purchase them in bulk of 5 packet of 5, and it's not costly. In fact, the whole packet of 5, right, is equivalent to 1 Noctua fan. So that's the reason why I don't use Noctua. To move on to this website here, whereby I make use of this application called Speed Fan. This is whereby you can actually manually control the RPMs of your fans itself, and to actually do the proper temperature curve. I do understand that motherboard do have such Q-fan controllers, or should I say a software application whereby you can actually do it either on a UEFI or application where you can actually control the fan curve. But I would trust this Speed Fan more than the motherboard software or UEFI itself. If you're interested to know how this application works, right, in fact I learned this through J2 Sense at the year of 2016, where he actually illustrated how to actually make use of this fan speed. I will leave this link from J2 Sense under my description, so if you guys are interested, you can actually click on it. Last question, is overclocking necessary? There is no right or wrong in overclocking, but as a personal preference for myself, right, I will let the motherboard do the decision, as in like when it needs the processing power, it will overclock. If not, it will just go back to the original state. I hope you guys are actually not falling asleep, and I've actually forgotten to mention why I did not fix the overclocking, as in like having a fixed voltage and the bus speed. Reason being, right, I had very bad experience in the past where I just fix a voltage and let it run, and in no time, less than about a year, my board die off. Reason being, right, the motherboard was actually warped badly and there's not enough cooling within the system itself. So from that day onwards, I've actually chosen to let the motherboard decide with the turbo boost function. These are the cases that I actually work with. I'm not sponsored, so I can't test any other cases except for this, because I base on their build and their structure. That's why I actually purchased them and to build them. Now, at the year 2013, right, I had this casing, the Fantex Onto Pro M SE Special Edition, but it's actually not in Singapore but overseas. I was actually working overseas. So if there is a chance for me to actually grab hold of this case itself, right, brand new, I will get it for sure, as compared to the current case that I'm actually using. Though the Lianli Lenku 2, right, has pack of functions, but if you were to compare the airflow, right, this will be definitely better compared to the Lenku 2. Another case which I find fascinating, which is quite similar to the the functions itself is similar to the Fantex P300A, 400A and 500A, and of course the Factory Design Mystify C, which is this very budget case, extremely cheap, Upcon Chrono 650. I've actually done a review on this case on another video. If you guys are interested, I will just leave the link on my description. You can actually have a look. I will also go in depth on why this case is good. Moving on to the Fantex Onto Pro M SE Special Edition. As you can see, that this is actually all the very modular case, I should say. You can actually take out most of the parts. Now, the ventilation holes, right, are good because they are actually honeycomb style. They do have the top ventilation, the front mesh ventilation, a very good mesh, or should I say fan mesh, similar to the top. This is actually a PC which I've actually done for a friend using this case, and as you can see that this is actually an entertainment kind of PC. It does not have a graphic card. You just use the onboard graphic card. Now, the way that I actually designed this, right, it's pretty straightforward. For zone 1 itself, right, which is actually the CPU itself, as you know that it the processor is actually dissipating all the heat to the radiator itself, and the fan is actually drawing cold air from the outside. And plus point, as I mentioned, that the mesh cover at the front that allows a lot of cool air coming in. So with minimal of hot air blowing towards this direction here, which is actually zone 2, the GPU zone, or should I say GPU area. He does not have that, so it's actually a bonus point. So to actually dissipate all this hot air itself, right, I've actually catered 2 fans above to draw air out, those hot air out. Okay, be it from the be it from the RAMs itself, or be it from the VRMs itself. And of course, at the rear, it's also drawing hot air out. But there is one problem with this positioning. Though it's having very good temperature, but this airflow, right, it's negative airflow. Meaning to say there are too much air going out, not coming in. And with this, right, it accumulates a lot of dust within the case itself. So cleanup can be a bit messy. Next will be the Upcon Chrono 650. Now this case itself, right, it's quite similar to the Pantex that I've shown earlier. It does have the front mesh, and it has honeycomb shape of ventilation, and of course the top where you can actually draw air or pull air in. Now having to say this, right, this case, I mean, this PC itself is actually meant for charity, so I actually pieced up together with some friends, and all the parts is actually contributed among the three of us. Now, how I actually cater this, right? Looking at zone 1 itself here, this processor itself is actually dissipating heat through a 120 radiator, which is actually located at the rear. So having to say, right, I pull the cold air in, and with the hot air coming off inside here, right, it's going to be drawn out from the two fans above. It's actually drawing air out, and from the front itself, right, it will just draw cool air without radiator, without anything. In fact, it's giving ample cold air, or should I say cool air. Now this is pretty balanced. I've actually tested it for a couple of weeks, and surprisingly, no dust on the case itself. It only happens on the front mesh itself and the back. So at the back, right, I did place a front fan filter, so not much dust is actually pulling in. So this is actually how it's been done. Now, last but not least, right, I will show you live on my Lianli Lianku 2. Now, just an introduction of my Lianli Lianku 2. The radiator is over here. Placing is actually 240 intake static pressure fans. Then at the top here, these two in fact are the intake airflow from Arctic, and back there is actually my gentle Typhoon, which is actually sucking hot air out. Then the PSU itself, right, zone 3 itself, what it does is actually it draws air from the beneath and to blow the hot air out from the back. So zone 3 is actually covered. I need not have to worry about this. Now coming to this section here, right, whereby zone 2, the graphic card itself, the main reason why I did this mode on the graphic card itself, right, this is actually a 1070 Ti Mini from Zotac. The original card doesn't look like that. I designed it such a way that it's like a box with the back having an opening. So when the AIO is actually pulling the I should say the heat is actually sucked to the radiator at the back, which is actually an ID cooling. So how it dissipates heat, right, is actually through this fan here that is sucking the warm circulation air. This is in full speed, okay, and for this, right, there are no heat dissipating out from this GPU itself, because it's designed as a box shape having the back as an opening. So whatever is actually blown inside, right, there's actually a fan here which actually blow on my graphic card itself, right, it will just dissipate heat from the back. So this is covered. The hot air will not touch us over here, nor the processing unit itself. So zone 2 is covered. Coming to zone 1, which is actually the processor itself, as usual, the heat is actually dissipated to my radiator and having the cool air sucking in from the front, right. Now, there are not much cool air sucking in due to the fact that my front bezel is not the open type of mesh, so there are limited of cool air pulling in. So in general, right, there are some warm air pushes through. So what I counter attack the warm air itself, right, is by pushing cold air from the top, pushing it down, forcing it to the back. And for this, right, for the VRMs and the RAMs itself, right, some will be sucked. Some of the cool air will start to cool the RAMs itself. Then some will cool off from the VRM, and especially for this Arctic liquid freezer itself, right, there is a fan that blows the VRM itself. So having both to blow the VRMs and having this fan to actually blow the RAMs itself, right, the hot air will dissipate through this full loaded, or should I say full RPM fan, the gentle Typhoon, will just suck the air out. Okay, just to show you, right, right now it's actually at idle. Let me just bring up another menu to show you what is actually going on. Okay, I've actually set my graphic card to max everything to, I mean, as in like, I've actually tweaked my graphic card. So as you can see, right, the temperature reading over here, okay, this is actually my call CPU. So minimum is actually about 35 degrees to 36 degrees, and right now it's 37 because I'm actually doing recording right now. Okay, then for the fan RPMs, right, as I mentioned, that I've actually made use of a program called speed fan. So these are my RPMs. As you can see that, okay, the first chassis 5, right, in fact it's my front intake of the radiator fans, the static pressure fan. Then chassis 6, right, in fact is my pump on my graphic card itself, is running on full. CPU 1 is actually the the processor pump that's running on full. And CPU 2, right, in fact this is the top fans that's running on 723 RPM. And for chassis 1 itself, right, which is running, supposedly it should run at 1800 RPM, which is actually my gentle typhoon of the rear. So right now I'm just going to show you that how the full load is. I'm just going to render this video here. Just take, for example, I'm doing all this, then I'll just render. When you render, right, take a look at the CPU. And mind you, right now I'm actually not on air conditioner, so it's actually on room temperature, and I should say that right now it's actually nighttime, so the room temperature is about 28, 29, around there, because right now in Singapore the weather is pretty hot. So as you can see, it's actually rendering. Then while it's actually rendering, right, you can see that my fan are ramping up. So most are at full speed, and it's quite quiet. I can't really hear a single thing. These are on the core temp. I am still rendering. This is actually a 4K video that I intend to compile. So as you can see that my temperature, right, will never hit 74 and above. See, it always hover around 70 to 74. It never goes beyond there. You see, the load of the processing rate is almost 100, and my temperature is still catching. It's like it's holding, not catching, I should say. There you have it, my experience on PC build and molding the airflow. So I hope this will actually let you understand more on your next PC build. Now, there are two things that I have not touched on, which is actually the radiator surface and the thickness of the radiator itself. Often when I purchase radiators, right, I will just go for a bigger surface area. Instead of getting a 240, right, I'll get a 280. I can actually get a 360, but they are more expensive, so I choose to be in between, which is actually the 280 radiator. And speaking of thickness itself, right, I like radiators that is actually 30 mm thick, or should I say not lesser than 30 mm, because in the market itself, right, the standard is actually 25 or maybe 20. Then when it comes to fan itself, right, I prefer to use 140 mm fans compared to 120. Reason being, right, I can run them at lower RPMs that generate more air to the case, or to actually suck air out of the case. Then another factor is actually the noise. Now for fans that is actually at 140, right, there will be a bigger area surface where it will push and pull. Okay, so do take note on this. Alright, wow, this is actually a very long video compilation. I hope that I've not bored you guys, so good luck with your next build. Thank you for watching. See you, goodbye.